Yeah. Okay. Thank you for having me today. So my name is Wesley. I work for a company called SAS Institute. Probably many of you know that. It's kind of a long-standing company in data and AI, and also in specific business solutions. So today, what I wanted to do is to talk you through, okay, how do we look at Agentic AI, and also to give you a practical use case. So it's a bit back to reality, I would say, after the session we just had with Peter, because I want to talk what is possible today, or what are we seeing with our customers that they are doing today with our software. Yeah, talking about agentic systems. So as you probably already know by now, kind of what are the components of a typical agentic system? And one of the key components is, of course, a large language model. But a large language model on its own, it's kind of just it's something that has a lot of knowledge. It's trained on a lot of knowledge, very wide generalistic knowledge, but it can't really act to anything. It's kind of the plain ChatGPT. You give it, you ask it a question, you get an answer. But it's only when you wrap that LLM together with some tools and some memory to adapt itself, but also hopefully with some guardrails, so it doesn't hallucinate, that it becomes something that can act in an operational environment and really do things. And that's when you start doing that, that's when people become kind of hyped. Because it's seemed to be something that can live autonomously and do a lot of stuff. And it is true, but if you look at the pure reasoning capabilities of a large language model, well, there are still some reservations, I would say, that you need to have, and you really need to scope your use case appropriately. So, as I said, with that hype, often people are now like, okay, we have a lot of fantastic solutions. What are we going to do with it? So they are looking really at AI strategy first before the business strategy. And like with every technology, it is important that it meets the bottom line, that it increases revenue or it reduces costs, but more importantly, that it is in a way that it doesn't increase risk. I think that's very important nowadays. And so, as I said, a lot of hype, a lot of capital that is made free at financial institutions to do something with these agents. But still, if you look at the research papers, a lot of these agentic applications or use cases are still stuck in pilot or in proof of concept phase. And I think that there are kind of three main challenges that they are facing. The first one is data quality, or in a broader context, data ingestion as well, because as I said, the LLM, okay, it has a wide knowledge, but it doesn't really know your enterprise context, doesn't really know your enterprise data. So you need to have kind of procedures in place to intelligently, efficiently infuse that specific enterprise context to your large language model. Think about RAG approaches, or think about kind of analytically pre-processing the data that you only feed kind of the right things to the LLM, and do that in a deterministic way before you arrive at this probabilistic a large language model. And then also metadata management. So so basically data about your data. What are the business context, the business terms on your data? Secondly, of course, compliance and regulatory scrutiny. So we have regulations on all levels. We have regulations on AI governance, on AI risk, but also kind of financial regulations like PSD 2 and 3 and the European Union AI Act. And they really ask you to build agents that are very responsible, that are very explainable. You need to be able to go through the reasoning steps, step by step. What was the input in each step? What was the transformation? What was the output? So observability is very important. And then lastly, the operational oversight. So an agent, it's not kind of a single call to a system. So if you launch an agent, you let it reason, it will launch a lot of sub-processes. It will make a lot of API calls, because that's basically what it does to be actionable. And if you have one error at the beginning of your process, it can have a combinatory effect. It can inflate at the very end. So it's very important to constantly evaluate kind of the output of the model and also the performance. Now, coming back to SAS, we as a company, what is our position here? What do we provide? And actually, we provide kind of operational layers, I would say, on top of foundational large language model components, specifically to overcome these hurdles that I just talked through. So we have kind of an agent orchestration layer that let you design an agent with all core principles. And then a kind of semantic and a data layer that gives you information, that gives you additional context about your data that then can be infused to the LLM. And in doing that, we are technology agnostic to the language, but also to the kind of platform underneath, whether it's kind of on-premise or it's on a public cloud. Also, very importantly, now we still very much believe in having a human in the loop. So maybe in the future, if hype becomes reality, we can remove that human out of the loop. But for now, I think it's very important also in terms of regulation that you still have the human in the loop. Thirdly, a blend of traditional machine learning model, also super important. Everybody, nowadays, AI is kind of GenAI, but it's not. GenAI is a part of AI, but you still have all of the other machine learning models that were kind of hyped a couple of years ago that for many people don't really exist anymore, but they are still very important. Having deterministic building blocks in your agentic systems is very much a key thing. And then lastly, we ensure, of course, the governance is in place. So coming back to the human in the loop, I think we kind of have three different flavors of human in the loop. That comes then with kind of its own risk and its own scalability. And so at the bottom, you have the human on the loop, where you still require human interpretation. Think of a report that can be built by AI, but not interpreted by AI. Then you have the human in the loop, where you kind of allow the AI to really make automated actions, but they're still monitored by a human. And then out of the loop where you completely let the agent do autonomous tasks itself without any intervention from the human. And you can kind of translate this concept towards use cases that we see in banking. And I think the key message here is that a lot of interesting, valuable use cases are not in the upper right corner or in the upper left corner. They are still very much supervised. We are still very much a human on the loop and a human in the loop, whilst bringing a lot of value with kind of the risk still under control. And so there are other criteria that we believe for a bank, if you would start with agents, are very, very good success criteria. So next to having that kind of decision where you put a human, you also need to think about, okay, how explainable is this agent that I'm building? How much measurable is this agent that I'm building? And does it really lower the risk in the organization? And does it also lower the costs compared to not having this agent? And so here I have another number of use cases, which I won't dive into, but there is just one that I wanted to talk through, and that's kind of the acceleration of case management. So this is a use case that we did together with a large financial institution, and the problem that they had is that they faced a lot of kind of operational ineffectiveness in the sense that they got a lot of emails from customers, kind of complaining, for example, oh, I see something in my banking app, I see that there was a withdrawal on my account, something happened. And then the fraud investigator had to kind of manually go through that email and link that then back to the account, to the transactions that the customer made, to maybe possible cases in their investigation interface. All work that they had to manually do even before doing really the investigation work. So that's a rather simple use case, but a use case that actually increases the cost for if you make the cost calculation per investigation, it increases it massively, and there is actually finally a lot less time to really do the decision making on these alerts. So then we thought about solution. What could be a possible solution? Build an agent, of course. But we build this agent really as being a supervisor and not a decision taker. So the agents had basically two tasks. First, extracting all the data, all the valuable data on the customer's communication, the email and the transcript, enriching that data with additional information that we have, transaction data, for example, or maybe beneficiary data. And then, secondly, based on that information, let the agent decide what kind of analysis, what kind of fraud typologies we think there are going on, and then execute that analysis according to the fraud topology. So if you look, okay, what goes into this agent? There are kind of there were two possible ways. One was kind of a bank-initiated conversation where the bank has its currently running decisioning engine that screens the transactions, that generate alerts. And so if there was an alert, the next step is that there was communication towards the customer to check, okay, have you seen something strange? Because we've identified some suspicious transactions. And on the other side, the opposite is true, where the decision engine didn't detect anything, but the customer called the bank saying, like, there is money going away from my account. In principle, it's the same thing. We analyze the customer information because with the first scenario, the customer sends also an answer back, and we try to link it to the case or link it to the transaction and kind of build all of the information building blocks that are necessary for an investigator to take action. And that's a bit what the outcome is actually from the agent. So what you see here is an investigation, or our investigation interface, where you have your suspicious transaction on top. You have a network graph on the right, where you have the transaction linked to other relevant entities, like cases or other initiators or beneficiaries. And then you have kind of a summary of what was going on that is provided by the agent to the investigator. In this case, it's like a customer did a payment from an unknown device at 3 a.m. from Vietnam, trying to pay to crypto by AG, etc. So it explains you what it is, why it happened, there was something wrong with an unusual device, etc. What fraud typology it is, it's an ATO fraud typology. And then also what the customer's feedback was. So, hello, no, I didn't make this payment. So this was kind of a bank-initiated scenario where we had a suspicious transaction, contacted the customer, and we got that information from the customer back. And then the investigator gets also some recommended actions. So it recommend, but it doesn't take the agent. So here, in this case, the agent doesn't take the action. It's kind of the human in the loop. The investigator is in the loop to block the transaction, to flag, to freeze the account, to verify the identity, etc. And the next step is kind of a more elaborate version of what was going on, and also provides additional information of the cross-checks that the agent made. So we checked, like, okay, this beneficiary, did he made or she made other suspicious transactions? The device, well, what is this device? Why was it? Was it kind of a new device for this specific customer, etc. And on the right, the agent executes actually the logic to screen the transaction based on the ATO fraud typology, and provides us kind of all of the resulting risk indicators of that screening. So that's a bit what we provided to the investigator. As I said, supervisor role. See it as a supervisor role. It speeds really the whole collection of that data, kind of the whole storyline of what is going on. It speeds up that process, but the investigator is still making the decision. This is kind of what's going on behind the scenes. So this is our, as I said, kind of that agentic orchestration layer that we have. This is the application that allows us to build all of the building blocks for the agent. And you see it's kind of a very kind of controllable process where you have a lot of different building blocks, reusable building blocks also, where you have a specific input, you have then something going on in the block and a specific output. So every step is here governed. You can make this as deterministic as you want, but you could also make it completely non-deterministic. Let the LLM reason as much as possible, connect it to tools through MCP, and make it very much autonomous. It's up to you to decide. In this case, we made it very deterministic. and we kind of added or used the LLM's reasoning on some places in a very controlled way. So if you look at the kind of the sub-agents, if you want, of this agentic workflow, so the first one was kind of the parser of the email parser that kind of screens the email, gets all of the necessary useful information for the investigator, enriches also that information, and then the next step is the payment or the alert analysis, kind of the payment verification that we do. And then the last or the third step is kind of collecting all of that information together from the other sub-agents and then sending it to the investigator interface. That's kind of the high-level agentic workflow that we made. So if you dive just a little bit deeper here on the payments verification, so within this sub-agent, we have then a lot of other kind of steps that we do. The first thing is we get context, we get additional data. We want to know, okay, who is that beneficiary? What do we have on that? Was there unusual behavior on that beneficiary, etc. And all of that additional context information is then, together with the email parser sub-agent, is then used to identify which fraud topologies are going on. And based on that, we will execute kind of the right branch. And in this branch, we will most often use a machine learning model. And if you use a machine learning model, it's very important that we are able to explain what the machine learning model predicted and why it predicted that. And if you use advanced machine learning models, you need to also calculate model interpretability statistics. And these are, for typical investigators, kind of hard to understand in its raw form. So here we use the large language model to kind of interpret that and convey that message in an understandable way to the investigator. And then at the end of this sub-agent, we collect all of the information, we send it back to the main flow so that it can feed again as input to another sub-agent. And that's a bit how we built this flow with deterministic and probabilistic elements in order to keep everything under control and to not avoid too high risk. So key takeaways here, from our point of view, so agents, they accelerate work, and that I'm talking now. Maybe in a couple of years things will change. So they accelerate work, they don't replace judgment. Secondly, hybrid AI makes agentic systems viable in regulated environments. And thirdly, governance must be built in and not added later. So I think if you keep these three things in mind, and you build kind of a governed agentic workflow, I think you can have value with agents now. And that's what I wanted to give you today.